Problem number 19. We want to evaluate the limit as x goes to 1 of x over x minus 1 minus 1 over natural log of x. So what's going on here? Let's try to substitute x equal to 1 just to see what's going on here. So we plug in x equal to 1. We'd have 1 over 1 minus 1 over natural log of 1. This looks like 1 over 0 minus 1 over 0. We're in an infinity over infinity. I'm putting lots of quotes here because this isn't equal to this. But we're in the infinity minus infinity indeterminate form. So whenever we have indeterminate forms, we should be thinking about L'Hopital's rule. Now, L'Hopital's rule does not immediately apply here. We need to do some manipulation first because L'Hopital's rule only applies if you have a 0 over 0 or infinity over infinity indeterminate form. So how do we proceed? What we want to do is we want to manipulate this so that we do have infinity over infinity or 0 over 0. And I'm going to proceed by putting everything over a common denominator. So I'm going to make the denominator x minus 1 times natural log of x. So I need to multiply this first term by natural log of x. So I'd have x times natural log of x. And then I need to multiply the second term by x minus 1 over x minus 1. So minus x minus 1. So at this new stage here, what happens when we plug in x is equal to 1? We'd have 1 times natural log of 1 is 0 minus 1 over 1 minus 1 times natural log of 1 here. And so sure enough, this is a 0 over 0 indeterminate form. We are allowed to use L'Hopital's rule at this point. Okay, so let's apply L'Hopital's rule. The derivative of the top function here, x times natural log of x, we need to use the product rule here. So x times the derivative of natural log of x, which is 1 over x, plus the natural log of x times the derivative of x is 1, minus the derivative of this over here is 1. Downstairs, we would have x minus 1 times the derivative of natural log of x is 1 over x, plus x minus 1 times the derivative, oops, I already did that, silly me, natural log of x times the derivative of x minus 1 is 1. Okay, does anything cancel here? So x times 1 over x would be 1, minus 1, those are going to cancel, plus natural log of x. Downstairs, we'd have x times 1 over x is 1, minus 1 over x, and then plus natural log of x. And so we would end up with those cancel out. Okay, what happens now? What happens if we plug in x in to 1 in for x here? We'd have natural log of x is 0 over 1 minus 1 over 1 is 1 plus natural log of x, natural log of 0, 0. We're still in infinity over infinity indeterminate form. So we need to apply L'Hopital's rule again. Okay, one more application of this. Derivative of natural log of x is going to be 1 over x. Derivative of the downstairs is going to be 0 plus 1 over x squared plus 1 over x. Okay, let's multiply the top and bottom by x squared to see what we have. And so we'd end up with the limit x goes to 1 of 1 over x times x squared is x, over x squared times 1 over x squared is 1, x squared times 1 over x is x. And finally, Thankfully, we can plug in x equal to 1 without getting an indeterminate form here. 1 over 1 plus 1. Our final answer here is 1/2. So morals to the story. Realize you have an indeterminate form here. That's not something you can immediately apply L'Hopital's rule to. So do a little bit of manipulation to get it to the desired form. And then we have to apply L'Hopital's rule not once, but twice.